Hey everyone, I'm Burhan with another tutorial on PCB designing using KiCAD. In the previous tutorial, we assigned footprints to all our components, and in this tutorial, we will explore the PCB layout editor. You can open your PCB layout editor by clicking on this name of your file .kicad underscore PCB, or you can open your schematic editor and from here click on Open PCB in board editor. This opens up a blank PCB layout editor and it's quite easy to use because it has the same navigation scheme and button as that of the schematic editor. So let's start by clicking on board setup icon. Under this, click on uh, board stackup. Here the layers are chosen automatically. These are different layers of PCB. Here F stands for front and B stands for back or front and back side of a PCB. Let's remove the unnecessary layers and also discuss some of them. The first one is f.courtyard and b.courtyard. These layers create a perimeter of safety around the component so that it does not overlap with other components when it is assembled. Let me show you how this courtyard looks like. This pink outline around the component is used to indicate courtyards. Then we have F-fab and B-fab. These layers are used to include additional information or key points and notes for the manufacturer without including them in the final design. We won't be using these two layers, so I'll disable both of these layers. Then we have F adhesive and B adhesive. These two layers would be necessary if any of our components is difficult to mount and we need any additional glue or materials for it. These layers therefore show where and how the glue should be applied. These two layers are also unnecessary for us right now. I'll disable them. Then we have F paste and B paste. These layers would contain the information about where the solder mask should be applied and where it should not be applied. Solder mask prevents our PCBs, which are made from metals like copper, from oxidation. Moreover, it prevents any accidental contact of our tracks with any conducting material. Solder mask is the red or green color which you find on your PCBs. Solder mask is to be applied at entire surface of PCB except at the places where we solder our components, and that information is contained in these paste layers. Then we have F silk screen and B silk screen. These layers contain the information about the logos, images, and text that we add on our PCB. Then we have FCU and BCU or front copper and back copper. These are the main and most necessary layers of our PCB because they contain information about the tracks and connections of our PCB. Then we have edge cuts. Edge cut layer determines the shape and dimensions of our PCB. After that, we have the margin. This layer determines where the PCB components, connections, tracks should be placed and where they should not be placed. So I'll turn off these user eco layers because these are used when I share my designs with any other engineers. These are used to add additional information without including them in the final design. I'll also turn off these user layers, uncheck them all. Click OK. Now you can see only the necessary PCB layers are shown here. Now go back to the board setup and under this click on physical stack up. You don't need to worry about this information. Most of this is to be taken care by the manufacturer. You just need to select your number of layers from here. After this, click on constraints. The values that a fabrication plant can handle must be entered here. KiCAD will thus alert us if we go beyond this threshold value and help us to keep our design within the manufacturing constraints. Different fabrication plants have different capabilities list which we can use to fill this information. The first parameter is minimum clearance. It is a minimum gap that can exist between two tracks. If this value is lowered, then the two tracks may short with each other. Then the next parameter is minimum track width, and it is essentially the thickness of track. And if this value is lowered, the tracks may result in open circuit in the PCB due to etching process. So it's important to apply this constraint and keep the track width always above the threshold. Then the next is minimum connection width. It's same as minimum track width, and it's the connection between two components or between a component and a track. If its value goes below the threshold value, then the etching process might break the track. Next, we have the minimum hole size. Then we have minimum via diameter. Via is same as hole. It's used to connect the different conducting layers of a PCB. Then we have copper to hole clearance. This is used to ensure that there is sufficient gap between tracks and holes so that the tracks don't get damaged during drilling process. Similarly, the next one is copper to edge clearance. This constraint is used to ensure that the tracks are not taken too close to the edge of the PCB. Next is hole to hole clearance. It assists in ensuring that there is sufficient gap between two holes, and it also prevents two holes from forming a single slot during drilling process. Rest of the constraints are self-explanatory. Now click on predefined sizes. Now let's predefine some track widths for our circuit based on current rating. The current flowing in our circuit is very low, like 400 or 500 milliampere. So all tracks will have same width. Let me predefine the track width based on power type, like AC power or DC power for demonstration. Otherwise, we predefine the track widths based on current rating. But if we use that thing here, all tracks will have same width. Moreover, we are not using any microcontroller in our circuit. In that case, we would keep the track width of power tracks more than the signal tracks coming in and going out from the microcontroller. Now, in order to predefine the track widths, we can use calculator tool of KiCAD. Click on calculator tool, click on track width. All these calculations are done in accordance with this formula here. So first I'll enter the current rating of the circuit, zero point 0.5 amperes. You can see that for the current rating of zero point 0.5 ampere, we have the track width of 0.11 millimeter, and it is less than the threshold. So let me increase current rating for demonstration purpose to 1 ampere. The required track width is 0.3 mm. Let me enter this now track width, predefined track width. Click on this plus icon. I'll use zero point 0.3 for DC power and zero point 0.5 for AC power. Then again go to board setup. Click on net classes. In the previous tutorial, we talked about naming the connections to make them easier to understand. Using net classes, we can create a collection of connections that have the same properties. For example, we can create two net classes, one as DC and another as AC. Now, instead of using the preset sizes each time you switch between AC and DC tracks, You can use these net classes to automatically assign track width. Now we need to associate these net classes with the connections we established in schematic editor. To do so, let me go to schematic editor. We have the connection names now. Like for this connection, I have the name as plus V, but the net class is set to default. So let me add DC net class to it. Just right click on it, assign net class. I'll choose DC. Okay. If I click on it, its net class has got updated to DC. Rest of the pins pertaining to this plus V are also set to DC. For example, if I click on this connection, it also has a net class DC. Either we can go through this process for each connection or we can go to schematic setup. And here we have net classes. Enter them here. Then for output, sorry, our net class is DC. For VP, we have AC. Similarly, for VD, we have also AC. Click OK, and we can see the net class has got updated. It's AC. For output, we have DC. Okay. There appears to be a small issue now. Only the connections with net name have been assigned a net class. But what about the connections which have no net name? For example, this connection. It its net name is default. It doesn't have any net name. So how can we assign? If I try to assign a net class to it, let me see. Seems like I can't assign net class to it. This issue could be resolved by assigning a net label to it. I'll assign a net label to it. Let me name it uh, adjust. Now its name has got updated to adjust its net name. But this process would become more hectic if we are doing the same thing for complex circuits. So there is a tool in KiCAD 7. The tool is net class derivative label. Click on it and choose the value. For this case, it's TC. Choose the shape. Let me keep it diamond. OK. And place it on the wire or connection to which you want to assign the net class. Click on it. Now you can see the net class has got updated to DC. It's very easy to use. Now I'll open the PCB editor to make sure that schematic editor is reflecting all the changes made to the PCB editor. For that, open the board setup, and in net classes you can see all net classes are assigned here. This is all for today's tutorial. In the next tutorial, we will start doing routing for our PCB. At last, if you like this kind of content, then you should think about becoming a channel subscriber.